Good afternoon. Welcome to my statistics video. Definitely don't think it's one of my strong suits and trying to figure out what exactly North Carolina wants in a lot of these standards. So this question is talking about a survey that's being done, and really we're trying to emphasize what two different words mean here, what sample means and what population means. So somebody's doing a survey of students at her school and what they spend on lunch. Reader interviews 50 randomly selected classmates. What is the population sample? So the sample is the 50. The population is all the students, as it says, how many ever students are in the school. So students are being sampled, not teachers, not staff, just particularly students. It can be students who don't eat lunch. They can buy lunch. They can bring lunch to school. Those are all part of the population, and it may be included in the sample. So knowing that's going to pop up on a couple questions as I go through the slides. So example from the release test, and I changed it into 2 questions, by the way. A reporter wants to know the percentage of voters in a state who support building a new highway. What's the reporter's population? Is it the number of people who live in the state? Well, everybody can't necessarily vote. Infants or people under 18 and some other groups. So nope. The people who were interviewed in the state. Now, this question isn't really about interviewing, even though it's a reporter. It's about voting. So nothing was really said about that. All voters over 25, and there was never a specification saying, hey, just 25. I could see maybe 18 if they wanted to say that, because you got to be 18 or older to vote as of when I'm recording this. All eligible voters in the state, that is indeed the population. Now, everybody that's eligible to vote didn't necessarily vote, and those people that voted, that is the sample. So E would be the answer for that one, and D would be the answer for population. Next question, sometimes you need to be able to pull random samples. So if a class is containing 12 girls and 10 boys and we got to choose 3, which one of these would be truly random? Would it be the first 3 names on the roll? Well, that's not really random, or the first 3 to volunteer. That's not random. A lot of times, line B would be higher performing students to an extent, not always, but sometimes. That would affect the randomness. Place the names of 22 students in the hat, mixing it thoroughly and selecting 3 names. That's definitely random. Selecting the first 3 students who show up to class tomorrow, again, not random. So sometimes you need to be able to pick out or identify ways to choose a random sample. Though one of the standards I think I do understand very well is you got to be able to identify, when given a situation, which one of these methods would be best to collect information. If you're using a computer to model an outcome based on probability, that's an absolute simulation. If you're doing a study by watching with no engagement, that's an observation. If you're comparing the outcomes of a treatment of a control group, or basically using the outcomes of a treatment and against another control group. So basically 2 groups, that's an experiment. More on that in the next example. And then finally, survey is generally for opinions, trying to collect people's opinion. So here's some sample questions on that. Student wants to determine the most liked professor at her college, which would be the best one to do. Now, though you could certainly observe which teachers are like or professors are liked, it'd be difficult to observe everybody, and especially for a long period of time, it'd be way better to do a survey. Meanwhile, next example, a researcher wants to measure the effectiveness of a sinus medicine. That one would need to be an experiment. And this is one of the ones where you would want 2 groups. You'd want to give the actual medicine to a group, and then you'd want to give a placebo to a group. So if both groups report feeling better about 60% of the time, that means the medicine doesn't really work. It's definitely not my field of expertise, but that's how I interpret it. But if the medicine group maybe is 90% recovery, whereas the placebo group is 40% recovery, So that kind of works into off that 90 of saying, hey, well, 90% feel better, great, but 40 of them was the placebo effect anyways. But that's a little bit too rich for us. We just need to know which method would be the most opportunistic. Margin of error and a couple questions here. So sometimes we do estimates and we're not exactly sure, like if it's definitely like exactly going to be 47% for a Democratic candidate. But anyways, the margin of error being plus or minus 4.5% means, so the outcome, the real percentage could be higher than that, as high as 51.5, or it could be as low as 42.5. With that being said, can we determine if the Democratic candidate will win? Well, at 42.5%, no, but at 55.5%, yes. So we can't determine it, no, but we can say there's definitely some chance there. Anything over 50 sounds like a win. Anything below 50 sounds like a loss, assuming there's two candidates. So a bit inconclusive there, but that's what margin of error means. So keep that in mind. We talk about using that in these two questions, these last two questions. Basically here, if I was to do a survey to try to find out students' favorite color, and I just asked one person what their favorite color is, and they said yellow. Imagine if I went around saying, hey, I did a survey, and I've determined that most of my students like yellow. Well, that's not necessarily true because I only surveyed one student. My margin of error is really high because I only surveyed one student. But if I survey maybe out of my 89 students right now, if I survey maybe 70 of them, then I could say whatever I'm getting for my answer, my margin of error is a lot lower because I've done a much bigger sample. So using that here, a police chief wants to collect a sample of speeds of 100 drivers on a road. The mean was 48.5 miles per hour, meaning the average standard deviation is 2.5 miles per hour. So much like margin of error, sounds like they could be higher or lower, 2.5. Most of them, most drivers, within a standard deviation. The police chief wanted to decrease the margin of error. Which choice would decrease the margin of error? Would we decrease the sample size down from 100 drivers? Nope. That would make the margin of error go up, or the margin of error go up. Would we increase the sample size like we were just talking about? Surveying more people brings your margin of error down. So we already know had to really be, well, it didn't have to be one of those, but when two answer choices work against each other, a lot of times it's one of those. Changing the time of day that the data is collected, no, though. Granted, there is some effects for time of day, like school zones and maybe rush hour and things like that, but that wouldn't help us with margin of error. Changing the road on which the data is collected, and people do drive crazy on some of these roads, unfortunately. Changing roads is not going to bring our margin of error down. So last question, another EOC sample. iSchool randomly selected 75 of 200 seniors to take a college entrance exam. The mean grade point average of seniors is 2.85. Standard deviation is 0.4. What could we do to, or which of the following statements is true? I'm sorry, the margin of error for the mean grade point average is about 0.057, or it's going to be 0.092. So these answers are competing against each other. So they give us the formula, and they do a nice job of breaking down what the pieces meant. Standard deviation is 2.85, and sample size, remember which one the sample is? It's not the 200, that's the population. I think if you use population, you get that answer. I didn't do it like that though. And meanwhile, the sample was 75. So if you put those into the formula as they told us, we do indeed get 0.092. The margin of error would decrease if the sample size were changed to 125. Now, we already used 75 and we went to 125. So we already increased, by doing this, we're increasing our sample or increasing the number of people we're surveying, which is going to decrease our margin of error. So we definitely want that one. And we don't want to increase or The margin of error would not increase by increasing our sample to 125, so we don't want that one. Well, with that being said, that's the statistics unit from what I can tell. Thank you so much for watching.